Given f of x equals 3x cubed plus 2x squared minus 53x plus 60, and knowing one factor is 3x minus 4, write f of x in factored form and then give the zeros of the function. Because we know 3x minus 4 is a factor of the polynomial, we can write f of x as f of x equals the quantity 3x minus 4 times some remaining degree 2 or a quadratic factor. To find the remaining factor here, we will divide the polynomial function by 3x minus 4. Remember, to perform synthetic division, we would want the first term of the divisor to be 1x, not 3x. Because of this, we will go ahead and perform long division. So let's go ahead and set this up as long division, where we have the dividend of 3x cubed plus 2x squared minus 53x plus 60 divided by the divisor of 3x minus 4. And now to start, we focus only on the first term of the divisor and the first term of the dividend of 3x cubed. We need to determine what times 3x will give us 3x cubed, which is x squared. And if we need to, we can always divide 3x cubed by 3x to determine x squared. Now we multiply x squared in the divisor, which gives us 3x cubed minus 4x squared. Now remember, we subtract, but instead of subtracting, we will add the opposite. So we can change this to addition as long as we change the sign of the terms inside the parentheses, giving us negative 3x cubed plus 4x squared. Adding 3x cubed plus negative 3x cubed is 0, and then we have 2x squared plus 4x squared, which is 6x squared. Bring down the next term, so we have minus 53x. And now again, we only focus on the 3x of the divisor, and now 6x squared, and determine what times 3x is equal to 6x squared, which is 2x. The next term in the quotient is 2x, so we have plus 2x above. And now we multiply 2x in the divisor, which gives us 6x squared minus 8x, and now we subtract by adding the opposite. We change this to addition, and then inside the parentheses we have negative 6x squared plus 8x. The x squared terms add to 0, and negative 53x plus 8x is negative 45x. And then we bring down the last term, so we have plus 60. And now we need to determine what times 3x equals negative 45x, which is negative 15, which is the next term in the quotient. And now we multiply negative 15 in the divisor, which gives us minus 45x plus 60. And we subtract by adding the opposite. And notice we have a remainder of 0, verifying 3x minus 4 is a factor of the polynomial function, and also the remaining quadratic factor is x squared plus 2x minus 15. And now see if we can factor x squared plus 2x minus 15. If it does factor, it will factor into two binomial factors. Because the first term is x squared, the factors of x squared are x and x. Now we want the factors of negative 15 that add to positive 2, which are positive 5 and negative 3, giving us a factor of x plus 5 and a factor of x minus 3. Now that we have the polynomial in factored form, we can determine the zeros. Recall the zeros are the x values for which f of x equals 0, which is when 3x minus 4 equals 0, or x plus 5 equals 0, or x minus 3 equals 0. Solving each of these equations will give us the three real rational zeros. For 3x minus 4 equals 0, we add 4 to both sides and then divide by 3. We have x equals 4/3. Solving x plus 5 equals 0, we have x equals negative 5. And solving x minus 3 equals 0, we have x equals positive 3. The zeros, again, are x equals 4/3, x equals negative 5, as well as x equals 3. Let's verify these zeros graphically by graphing the polynomial function and determining the x-intercepts. I've already set this up using Desmos. Notice we have 3 x-intercepts. From left to right, negative 5 comma 0 verifies negative 5 is a 0. 1.3 repeating comma 0 verifies 4/3 is a 0. And 3 comma 0 verifies 3 is a 0. For each of these x values, notice the y values or function values are 0. I hope you found this helpful.